All right, then. This answer key is online, and I'm sure you noticed, but I put all three answer keys right there under yesterday's Canvas. So I assume that you're done. You should be sitting here today with all three practice quizzes done, maybe a couple of lingering questions. I hope, right? That's kind of where we should be. So question number one started out as something that we're pretty sure we know what it is, right? What can we tell it's going to be? This is the one where we're just pretty sure. What is this before we even start? Yeah, we know it's going to be grouping. Like that's no secret. But what we don't want to do is rush in and start grouping yet, right? What we want to do is get in there and pull the GCF out. So I'm going to pull out a negative because it starts with a negative, and I'm also going to pull out an X because everybody has an X to offer. That is critical, step one. And then what's going to be left behind is positive X to the third, positive 7X squared, negative X, and negative 7. And again, my advice is to either physically take the GCF and move it aside, or just be strong and say, I'm going to put it out of my thoughts. So like, you don't have to physically move it as long as your focus is just on the white stuff. Ignore the red guy. So I'm going to draw my wall down the center. The greatest common factor of these two terms right here is X squared. And then that's going to leave behind X plus 7. And then the next step that is in your notes would be very bossy in your notes. Tell yourself exactly what to do. Bring your minus sign down. And then you can't get anything out of X and 7, but you do need to pull it as a 1. And then that leaves behind X, and you do have to change the signs. So this changes to plus 7. And then at this point, we build our factors from what we see. The white will make one factor. The yellow will make another factor. So X plus 7 is a factor. And then the yellows, X squared minus 1, make up the other factor. And at this point, you have a couple roads you can take. Road 1 is if you identify that it's done, then you pull the GCF down and put a box around it. Path 2 is to say it's not done. And this one is obviously not done because X squared minus 1 is a difference of squares. So it factors down into X plus 1 times X minus 1. And then you bring down the X plus 7. And then you bring down your GCF, and then you put a box around it. And we're sure it's done at that point because there's no more meat on the bone. You can tell there's no more X squareds or X cubes to even have potential to have more life in them. So any questions on that? All right, then. Problem number 2, there is no GCF. The first step should always be to pull a GCF, but if there isn't one, then there's nothing you can do. This is just a, what's this called? What is this? It's a difference of cubes. Good. And when we come up against cubes, we know it's cubes because we know that we've done enough of this that we recognize those numbers, first of all, from our cube roots sheet. And we also, the X to the third is a pretty good giveaway as well. So we're going to find A, which is 7X, and then we're going to find B, which is 9. And then we're going to build a short set and a long set. And we're going to plug them in based on the formula that's in our notes. And it's, remember, it always goes AB, A squared, AB, B squared. Like, it's just a matter of the signs. And so since the original problem has a minus, then the minus will get spent early, and then we'll have pluses for the rest of the pathway, the rest of the journey. So the short set is A minus B in this case. So that's just going to be 7X minus 9. And then the long set starts with A squared, and 7X squared is 49 X squared. And then the middle goes A times B, 63X. And then the back is B squared, which is 81. That's it. There was no GCF. There's no multiple steps. That one is just a quick, that's probably a 1-minute problem tops.
And I don't understand how the x, the 7x is squared, and then it's 49, and then it's squared again.
It's because if you take 7X and you square it, because that's what this is A, right?
Yeah.
Then that's like saying 7X times 7x. Remember that that's what it means to square something, is to multiply it by itself.
Yeah.
And 7 times 7 is 49. And x times x is x squared. Does that make sense?
Yeah.
Good. Any other questions on number 2? Okay, number 3 is hidden from you. Well, what we know going into problem 3 is we know what it's not. So when we look at this, we know it's not grouping. We know it's not a difference or a sum of cubes, and we know it's not a difference of squares. So really the only 2 that are in the running are grouping and just old school quadratic. And so let's pass judgment after we pull the GCF. What is the GCF? What can you divide 6, 9, and 60 all by? 3. And we can also get x squared. Good. And that's going to leave us with 2, with 2 x's remaining, plus 3, with only 1 x remaining, minus 20, with no x's remaining. And then, as always will be the case, I've tried to do good with my colors, that the red is just out of our thoughts now. Short term, just put red away and just focus on the white. The white is the actual math problem that I want you to do. The good news about this is that it's definitely just a simple quadratic. We know it's not a lookalike because the exponents aren't buffed. The exponents, if they go 2, 1, 0, then you know it's just an old algebra 1 quadratic, like old school. So, and 2 being prime in the front is excellent news, because then we know when we divvy, there's no wondering, does it look like this? We know it's going to look like this. We also know that the signs are plus and minus. So just slap them in there, and if you have to reverse them, no big deal. And then if you do a 5 and a 4, if you put a 5 here and a 4 here, you get kind of the dynamic that you want. It's just not quite perfect, because you get 5x and minus 8x, which make rats negative 3x, and we wanted positive 3. So yeah, just switch the signs. So instead of plus then minus, we want minus then plus. And then you can remultiply it out to verify it. But I mean, if you already got negative 3, then you know this is going to give you positive 3. And then, I see it all the time. Every year on this quiz, I probably take off a few dozen points for people saying, I'm done, because it sucks, like it's no good, but you got to remember to bring this down before you put the box around it, because that's part of the answer. All the parts and pieces that you've pried off are parts of the answer. So as you go, don't lose track of things. Any questions on number 3? Okay. What is number 4? It is. And some people would call it a lookalike, and technically it kind of is, but for the sake of your notes, don't call it that. Just call it exactly what Jordan said. It's a difference of squares. It just happens to be a buffed up difference of squares. And so when I do a difference of squares, I want to be really patterned about this. So the way it goes is you basically just do square root, square root, square root, square root, right? That's how difference of squares has always worked. So like the square root of x to the 4th is x to the half of 4. And then the square root of 1 is 1. And then you just put a plus and 1 and a minus. But we're not finished, right? So this would be an example of a problem that's worth a little bit extra, because you're going to get 3 points or so for getting that far, but then you're going to get 3 more points for going further, because you recognize that that is a difference of squares. This one's dead because it's got a plus. Squares don't work with pluses, right? But we're going to go that one step further and leave the dead x squared plus 1, and then break the other guy down into x plus 1, x minus 1. And then box it up. There was no GCF to keep track of, so we could just box that up. Questions there? What is question 5? For sure. There is no GCF, so we can just hop right into question 5 and just call it what it is. I haven't really modified and written this year's versions of the quizzes yet. I'll do that either throughout the day or this evening at home, but I can tell you that probably more than half the problems will have GCFs. So I would say out of 12, maybe 7 or 8, if I had to guess. So just always watch for it, but there isn't one. So you're like, okay, I can move past that. And with a lookalike, we treat it just like a quadratic. You essentially factor this red one, this white one, exactly like you would factor this red one. Old school. You just have to be aware that, putting like on this red one, you would just do x plus 9 and x minus 4, right? That's an old algebra 1 quadratic. We do the same thing over here. We have to buff a little bit. X to the half of 4 and x to the half of 4. And then the structure of it is still the same. And that again is why math people call that quadratic form, because it's like built like a quadratic. Right. Done?
No.
Certainly not. Again, this is going to be one where you get some points for going this far, but then you get more points for going further. That, of course, is a difference of squares. This is a sum of squares, so it's dead. So we're going to copy down the x squared plus 9. And then we're going to break this little fella up into x plus 2 times x minus 2. There was no GCF, so we box it up when we are done. One more to mark the halfway point. Any questions on 5? Okay, question 6. What is it? Yeah, it's grouping, and it does not have a global GCF, right? So when you look at the whole thing, problem 6, there's nothing you can get out of all 4 terms at the same time. So we can bypass that first step and just go right into the wall. So we have x to the 4th plus 6x to the 3rd minus 8x and minus 48. Again, you look through, there's nothing in common, so you just proceed, draw the wall. What's the GCF of this left side? X cubed. Leaving behind what? Good. Next step. Bring your minus down. And what can you get out of 8x and, did I copy that wrong? 48. I put 4, it's a 48. You can get an 8 out of both of those, right? So we're going to pull down an 8. Bless you. And what does that leave behind? Right. And I asked this question yesterday, I think it was 8th hour. I asked someone, why did you change the sign? Someone at some point in the day said, because I want it to look like the other one. And again, the answer is not that. Right. It's because we pulled a negative. We're not making it look like that one. We're just hoping that it does. And so just let it happen. Don't fudge it. But because the white things are the same, then they're going to make up one of our factors. And so I am on one hand proud of someone that can get this far. But for like the 4th time or 3rd time today, you're going to lose a bunch of points if you stop, because why? Yeah, this purple thing is a difference of cubes. So when I think cubes, I go to my notes and I have these keywords. There's 6 things that you should have written: A, B, short set, long set, A, B, short set, long set. Like, it's good to have those words that make us like jumpstart our thinking. A, B, short set, long set. So before I can proceed, I need to know who A and B even are. So who's A?
X.
Yeah. So A is X. What's B? Nope.
Just one.
Nope.
Oh, 2.
It's 2.
Sorry.
You're fine. So remember that A and B are arrived at by taking the cube roots of the things that you see. They're not what you see. They're the cube roots of what you see. And then having said that, we're going to pull down our dead x plus 6, and then we're going to build a short set and a long set. What's going to go in shorty? Long guy.
X squared plus 2 plus 1.
As always, at the end of a problem, just go back, give it a once over. Nope, no GCF. Box it up. Done. Questions on number 6? If we look at something like problem 7, who's a candidate? Like, I know that I'm not ready to say what it is yet, but just for my mental preparation, what could number 7 be? Maybe. What could it not be? Like, it's not grouping, right? It's not a quadratic trinomial, and it's not a lookalike. So at this point, it's down to one of the three shorties, and the shorties are sum of cubes, difference of cubes, difference of squares. It's one of those three, right? Let's find out what it is. And how are we going to find out? How do you expose the problem? You got to pull out something. And the negative is one of three parts that I have to pull out. I do agree that I have to pull a negative out because of that, but there's a lot more. What else can I get? I can get a 6. They're both divisible by 6. And how many x's can I get? 2. Good. Now we're going to reveal this problem for what it is. We're about to find out what it is. So what's left of the first term is positive x to the 11 minus 2 is 9. What's left of the second term is positive. The 6 dies, and there are no x's left. So when I gut an entire term, when this entire term gives its whole self to be the GCF, then we have to put a 1. And if that were the whole problem, I'd be like, great job. You get like a point, right? But now the problem actually begins. So what is the white thing? What's it called?
A sum of cubes.
It is called a sum of cubes. So the GCF is just going to kind of hang around like a bad cold here. And before I press on, I want to know who A and B are. With cube problems, that's an important step, is to say what's A and what's B. What is A? It is not. It is x cubed. Yes. So when you want to find A or B, if there's already an exponent, you have to divide it by 3. That's how a cube root works. So if it had been like x to the 21st power, then A would be x to the 7th power. Divide by 3. So now we have our cast of characters. A is x to the 3rd. B is obviously 1, because the cube root of 1 is 1. And we're going to now build a short set and a long set. What's going to go in short set? Yeah, A plus B. Long set to the 6. Good. Minus 1 times x to the 3rd is x to the 3rd plus 1. I've said this, I don't know, maybe a dozen times. Here comes number 13. Let's make it a baker's dozen. The long set will never be factorable. So that's dead. And this is dead. The only thing to worry about is this green thing dead?
Yeah.
It is not. What is it? What is it?
Sum.
It's a sum of cubes. Remember that sometimes a factor can make more factors. The offspring can produce more offspring. And so in this case, that thing that I do not have crossed out is now our new math problem. When you recognize a factor is not dead, it is your new problem. It is your focus. So you put everything else aside and you reset it. We go again, round 2. What is A?
X.
What is B?
1.
Correct. So what I'm going to do at this point is I'm going to copy down the greatest common factor. And I'm going to build into this. The order that you do this in is irrelevant. Whatever anyone tells you, it doesn't matter. Multiplication has, it subscribes to something called the commutative property. I don't even know if we still teach that in school, but it's simply a property that says multiplication can be done in any order and you'll get the same answer. The same thing for addition. So if anyone ever tries to tell you that the order matters, that's just, they're imposing their personal preference on you. Okay. So I'm going to go ahead and just wedge a new short set and a new long set in. And then I'm going to take this one and just bring it down as a copy. Could that have gone early? Yes. Do I care? No. Like what I'm looking for when you're done is all of the pieces. I will say this, the GCF generally should go out front. That's what anyone would tell you. Like putting it in the middle is just weird and creepy. But beyond that, it doesn't matter. What's my short set going to be? X plus 1 long set?
X squared minus X plus one.
There it is. And again, long set is never factorable. And so we had a long set up here that we knew wasn't factorable, and a new long set here that we know is not factorable, and nothing else is going to produce any fruit. So we just box this up. And we're done. Any questions on number 7? Yes, sir. This right here is a sum of cubes. Any other questions on number 7? Okay. Number 8. Good morning. Thanks. What is number 8? There is no GCF for the record, so we can go ahead to the what is it step. It is a lookalike. And if I'm someone sitting here right now who doesn't know why you said that, why can we say it's a lookalike? Like, I don't want to try to teach it. I just know what it is. That's fine. It's the pattern of the powers. Big even exponent, half as much, none. Even half, none. I would put that in my notes. I should try making my own page of notes someday for one of my own quizzes and see how it would compare to one of yours. You just got to have those little key thoughts. Yes, if the first exponent is even, like bigger than 2, so like 4, 6, 8, 10, something like that. And then the second exponent has to be exactly half as much as that. So you see how the first exponent's 8 and the second one's half of 8? And then there is no exponent on the last term, no variable, you know, that's how you can tell. Good. So if it's a lookalike, then we just treat it like a quadratic. Like structurally, what we do is no different than what we've been doing. And that is to take and put half of your x's here and half of your x's here. What are the signs going to be? 100% minus minus, because they multiply to make a positive. And then what numbers multiply to make 36 that we want? 9 and 4 will work just wonderfully. You would lose a metric ton of points if you were to stop here. Why? Because they both can be factored, right? I recognize that this is its own difference of squares, and I recognize that this is its own difference of squares. So each of them will produce 2 offspring. So from the green, I'm going to have 2 factors, and from the purple, I'm going to have 2 factors. So the greens are going to be x plus 3, x minus 3. The purples are going to be x plus 2, x, excuse me, I got to fix this, x squared plus 3, x squared, and x squared.
But you can factor down X squared minus X.
Under certain circumstances, if I really wanted to, I could make this problem have another step. And I've had problems like that on there before. You might have seen them before. But the thing is, 3, oops, well, this one's dead and this one's dead because they're pluses. But 3 is not a square and 2 is not a square. So if I really wanted you to have to do more work, if I wanted this to be like a really long problem, then I could have changed like this 4. I could have made be a 16, because what's the square root of 16? And then I could have forced you into a position where you'd have to break down x squared minus 4 subsequently again. But in this case, I wanted this one just to die here. So this is the final answer. Right. There's potential there. When you see all those x squareds, difference of squares is in play. But if the numbers don't agree, then we don't proceed. Right. 3s and 2s are dead. Questions on 8? Okay. Number 9. We can look at number 9 and say this. It's not grouping. It's not a lookalike. And it's not a quadratic trinomial. So again, like I said about problem number 2 or 7, I know it's either a difference of squares or a sum of cubes or a difference of cubes. I'm going to ask this question, and if you don't know the answer to this one, tomorrow's going to be a really rough day if things don't change. Why do I know it's either cubes or squares? Why do I know? This is not a difficult question, and if you don't get this one, I am worried for you and your grade. Why do I know it's either squares or cubes? Yes. Do you not have it in front of you? Why do I know that this is either squares or cubes? Because there's only 2 terms.
It's 16x.
So if we go into it knowing at least what it's not, and we know probably kind of sort of what it's going to be, but let's expose it and make sure. And how are we going to expose it? Pull the GCF. That's always the right answer to that question. Always the right answer to that question. Pull out whatever you can. What can all of these things be divided by? 2 and x to the 10th. Someone earlier yesterday and I were talking about how do you know what the GCF is, and it's just a comparison game. This one has 13 x's and this one has 10, so you just take the smaller one, right? If there's like 3 x's, just take the smallest. That's always going to be the GCF. All right, so what's left if we pull all that red stuff out?
Third plus 27.
Done. Now we're sure. We are locked and loaded. What officially is the white problem? What is his name? He is a sum of cubes all day long. And the moment I say that, or you say that, or I think that, I immediately go into AB short set, long set mode. So I'm going to say that A is what?
2x.
2x. And B is
3.
3. That's it. That's your ticket. If you know A and B, now all you got to do is just follow the template and just boop, boop, just airdrop things into their happy little homes. That's all you got to do. So my short set and my long set.
Plus 3. 2, 4, minus 6x plus 9.
Good. And that is almost that. I got to bring down my GCF. I know I'm done because the GCF isn't factorable. Like, that's weird. The short set is linear, meaning it doesn't have anything above x to the first power. So it's dead. And as I've said now, this will be 14 times. The long set is never factorable. So you don't cross that out like I did, but box it up. I was just trying to make a point. Good. All right, that marks the 75% way. So that takes us down to number 10. What do we know number 10 is not? It's not grouping. What else is it not? I really thought you guys would all have this with you here. I'm sorry, I should write it down. I just thought you'd all have them out in front of you because I don't know what I guess I made a bad assumption there. That's my bad. We know it's not grouping. What else for sure is it not? Yeah, I mean, it's probably not a lookalike because of the structure of the exponents. I mean, you can't really pass that judgment until the GCF's out. What is it not? is really need to focus more on these things. What is it
So-
not? It's not cubes and it's not squares. Why?
Because there's the.
Because there's three terms. It really narrows it down to where I'm looking now. I mean, I got to get the GCF, but as far as where I'm thinking in my notes to go, it's not grouping, it's not squares, and it's not cubes. That leaves us with very little possibility as for what it is. So let's start by pulling out the GCF. What can come out?
10
Negative
X. X and X.
10 and 1x, just like that. It's the best you're going to do. And then we're going to expose the problem. We're going to get eyes on what we're supposed to do. What's left of the first term? Second term?
X.
Last term? Said this before again and again and again. Once you're really good at factoring, this will inevitably be the one you hate the most. It's ironic that the one we teach you in Algebra 1 is just the one that continues to be the hardest, because this is the one that there's really no magic formula for. It is. And this one's not quite so basic just because of the 8, but these ones are the worst. Everything else I feel like has a formula to it. This one is just get in there and do it. So I guess I'll bring down my GCF so I don't forget, and then I'm going to build my 2 shells. And if there's one thing I can tell you, it's that, you know, there are tricks to make this a little bit easier. If you put 8 and 9 here, they never get to multiply by each other. Do you see that? And that's good, because if they did, we'd get 72 and we'd never be able to recover to get back to +1. So by putting them in the same factor, we remove their ability to get together. So yeah. So we know the structure of it has to at least go like this, right? Because of the way we want them to multiply. And then again, once you start getting good at this, it clicks and you understand the balance of power. You're in control of that balance of power. You want the positive answer to be bigger than the negative answer because of the purple number on the board. And so we want to give the plus to the 9x and the minus to the weaker 8x, like that. And if that doesn't make sense, then you just do it the way you've always done it, and you build your templates, 8x, 1x, 4x, 2x, and you just get down with your bad self and, you know, try stuff until it works. When people say, I need help with this one, I'm always like, you really don't. You just want someone to walk through it with you. But at the end of the day, factoring a quadratic is nothing that I can be of assistance with. It's just you trying numbers until it works. If you don't know signs, like if you think there was a chance in hell that those were both minuses, you're never going to get it. Like you got to know the basics, but then the part of it that you think you want help with, you don't need help. 9 1 1 9 3 3 8 1 4 2 2 4. Who knows, right? So, anyways, this is the final answer. That's that. Questions there? All right, number 11. Who's in the running on number 11? Like, who could this be? Difference of cubes is in the running. What else is in the running? A sum of cubes is in the running. What else? One more. Difference of squares. It is one of those 3. And again, why am I so sure? Because there's only 2 terms. There we go. Now we're cooking. 2 terms tells us exactly what we're probably headed towards this or this or this. Let's figure out what it is. So to figure it out, what do we do? Pull your GCF. What is the GCF of this nightmare? What can you divide 298 both by? 2. And how many X's can I get out? Just 1. So the moment of truth, it's called the reveal. What's left of 200XXX when you pull out 2X? 100? 100x to the tooth, right? If you had x to the 3 and you pull out 1, you're left with x to the 2. Huh. And what's left of minus 98x? Still minus, good. 49, and there are no x's left. The reveal is complete. And now we're sure it's a difference of squares. We knew kind of going into it what it could have been. Now we're locked in. We are sure that this is a difference of squares. And I'll say again, the key to a difference of squares, it's like a formula, is just square root, square root, square root, square root, plus, minus, done. What's the square root of 100x squared? So I put a 10x here and a 10x here. What's the square root of 49? So I put a 7 here and a 7 here. And before I get too excited, bring down your GCF, put a box around it. Dunzell, Washington with that one. Any questions on number 11? Okay, that leaves us with one more problem. Number 12. And by the way, I'm recording this. So if you wanted to go home later and go, like if I scrolled too fast or something, you of course can watch it, pause it, rewind it, whatever. Number 12 starts, well, I'll just write it out here. What is it not? Heck yeah. We know it's not cubes and squares, it's too long. And we also know it's not grouping, it's too short. All right? It's right in the middle. So it's either going to be a lookalike or an old school quadratic. Let's find out. It's got a lot of potential to be a lookalike just because the funky nature of those exponents. That's my guess. Let's pull some stuff out. What do we pull? Do better. There are 3 parts to this GCF. I pull this negative. Good. I pull that 3 and I pull 1x. Any part of that is missing. Problem over. So here we go. We're left with x to the 6 plus
S to the third
third.
minus 8.
The reveal. There it is. What is that? What is that? Yes. And again, we know it's a lookalike because the exponents go big even, half as much. Not. So we go right to that section of our notes, and in our notes, it'll say something like, hey, just treat this like a quadratic. So when you factor a lookalike like this, then you just build your 2 shells and you just put half of your x's here and half of your x's here. And then you better know your signs. Huh? What are the signs? Yeah. Oh, no, you didn't. And it's just like a quadratic. 4 and 2 will not work. I'll save us the time. 8 and 1 will work because 8 and 1 make 7. 8 here, 1 here. Let's make sure that works. 8 of those minus, oh yeah. I'm pretty sure there's a lot of meat left on this bone. What is that? What is that? Holy smokes. Ooh. So for the purple one, A is X and B is 2. And for the yellow one, A is X and B is 1. So our answer is going to look like this. Negative 3x. You know what? I would feel better if I made that red. Take that. So we're going to have negative 3x, short set, long set, short set, long set. Huh? Oh, thank you. I think I'm nice all the time.
Yeah, not problem, should say.
So short set for the purple guy is long set.
Plus 4.
Yellow.
X minus 1. And then x squared plus x plus 1.
Oh, sorry about that. How do we know we're done? Because you can't ever factor the long set. Right. And that's really all that might even have meat on the bone, and long set is always dead. So that is that. Let's make this official. Let's seal this up. Let's put it in a box. Boom. Please box final answers. That way there, I know what you've committed to and I don't have to wonder. Okay. Ew. I can. I'm going to stop this here recording first. Hold on a second.